Hello, welcome to the introductory video of IIoThink, Industrial Internet of Things Educational Lab. Today we'll go through the IIoThink educational software that provides basic engineering knowledge to students and interns. After passing the IIoThink course, they will be able to build better products and get hired faster, thereby fulfilling the continuous increase of engineers' job demand. The Internet of Things is exploding, connecting things, enabling an exchange of data never available before. IoT is changing the way we live and work. It connects smart things, from home appliances to cars, from sensors and valves in the factories to energy grid. It is estimated that by 2030, number of connected devices will reach 125 billion. Extensively growing IoT is becoming fourth top technological driver of change, and according to the McKinsey Global Institute estimations, IoT alone can add $14 trillion economic value by 2030. The growth of the industrial IoT increases demand for engineers and creates new high-tech jobs. Currently, 51% of human resources in organizations have insufficient understanding of IoT disruptive changes, which results in estimated 37% of workforce strategy that is not aligned with the innovation strategy. Almost 47% of organizations are lacking the skills required for IoT development, integration of new technologies, and meeting demands of tomorrow. Nowadays, the traditional courses in the universities do not cover the basic knowledge related to the industrial IoT that will enable software and hardware engineers to collaborate. Traditionally, universities prepare students with different specializations such as electrical engineering, hardware engineering, computer science, but IoT demands multidisciplinary knowledge, which is currently not given by most of the universities. Seeing the demand for special courses and knowledge, we have created IIoThink. IIoThink Lab is designed to reduce the gap between electrical engineering and computer science students who very often want to collaborate or need to work together in organizations to build products of the future, which require both engineering and programming skills. IIoThink is a 3-month introductory course for onboarding into the knowledge of sensors, actuators, data acquisition, connectivity, cloud computing, data analysis, etc. The lab is an educational software which consists of a special courseware and a trainer kit that teaches about the industrial Internet of Things. The product includes not only the full curriculum with detailed instructions, but also the special software which works with IBM Watson and NI System Link cloud technologies, and the hardware platform so students can have their hands-on experiments and understand how things are designed. The comprehensive courseware covers various IoT disciplines such as data acquisition, statistical analysis, cloud platforms, data transmission methods and protocols, and much more. Being a software specifically designed for industrial Internet of Things, it is built on industrial platforms so that students can learn on the devices they are going to work with in their future career. IIoThink Lab is based on National Instruments MyRio and Elvis 3 platforms. Now, let's dive into the software and start building our first connected device. Currently, IIoThink Lab includes 10 labs, 6 fundamental labs, 3 project-based labs, and advanced programming lab. Fundamental labs introduce students to sensors and actuators, data acquisition systems, control systems, various methods of sensor data conversion, statistical analysis, and data transmission IoT protocols. Project-based labs are advanced labs where students build small projects based on the gained knowledge. These labs are temperature monitoring system, warehouse management, and remote irrigation system. The last lab introduces students to the basics of programming IoT device in Lab View with System Link API. On the left side of the main screen, there are buttons to access Home Screen, the online help, hardware configuration, email settings setup, software upgrade, and About Screen. About Screen provides version and contact information for the support. Before connecting to the hardware, open the hardware settings screen, find your device and update the firmware in case you set up the hardware for the first time. The software will show currently installed firmware. The software allows to email lab reports to the trainers. Open the email settings screen to configure email settings and recipient email address to automatically send the reports. The online help includes short courses for each of the topics covered by the labs. The short course provides required theoretical knowledge to complete the labs. The online help includes also detailed task description and instructions for the hardware wiring and performing the lab work. For each of the labs, short course provides detailed information on the subject. For example, remote irrigation systems, how weather conditions affect irrigation system, different sensors and actuators used in such systems. The case study section of the manual discusses exact sensors used in the lab, their operation principles and other details. Now let's start with the first lab. Let's select Data Acquisition Lab and perform it from the very beginning. Structure of all the labs is common. Here you can see the task description, wiring instructions, hardware configuration, execution and quiz sections. Detailed step-by-step instructions are given to make the lab implementation straightforward. Now let's perform hardware wiring according to the instructions. Define here wirings done. Now we can go forward to the execution screen. To showcase main principle of the data acquisition, which is Nyquist theorem, we generate here sine wave signal which is being read back with analog input channels of the NI Elvis. Students should specify sine wave parameters and by changing the sampling frequency, check out how the sine frequency and sampling frequency ratio affect the acquired signal. Let's now transfer the acquired data to the cloud. IIoThink supports IBM Watson and NI System Link Cloud platforms. To connect to the IBM Watson, we need to generate a device ID and enter it to the Watson platform. Starting the data transmission, data acquired on the hardware is sent to the cloud. While performing the lab, students can generate graph screenshots to use them in the final lab reports. The last section of the lab is the quiz, where students are given 4 different questions to check their understanding of what they have learned during the implementation of the lab. Once the quiz is completed, generate the report, which is automatically sent to the trainer. The report includes all the screenshots, task description, and quiz results. Let's implement also one of the project-based labs, remote irrigation system. We need to perform all hardware connections according to the wiring instructions. We are done. Let's start configuring the system. We specify resistors used in the hardware setup and enter irrigation information. Depending on the information of the last irrigation done in different zones, the system will automatically control the irrigation based on the specified information and weather conditions, which are simulated using photocell and thermistor. You can simulate temperature increase by hand, raising the temperature of the thermistor. Weather information can be sent also from the cloud. Open the cloud communication screen, specify system link details such as URL and API key, as well as tags. This lab shows how IoT can enable remote control of industrial applications, providing flexible and fast response to external conditions. The last lab work teaches programming of IIoThink in LabVIEW graphical programming environment with System Link API. The lab starts from the simplest functionality, creation of tags, and end with more advanced creation of systems, such as temperature monitoring system. Each lab provides main building blocks, functions to program the thing. Let's do one of the labs. The purpose of the lab is to send data with specified tags to the System Link cloud. We are going to send temperature, alarm, and status tags. Here we already have completed code. Let's now start with the cloud data and dashboard creation. When we run the code, specified tags should appear in the System Link cloud. Now that we have the tags, we can create a dashboard and attach the tags to receive the data. We need to create 3 tiles: number to receive the temperature, text to receive the status, and status to receive the alarm signal. Run the code and change values of the tags. They appear on the dashboard. We have successfully completed labs, got sensor data, used it in our systems, and even sent them to the cloud platforms. Thank you for watching IIoThink video.